We have come to the question number 9 of the model paper. We use this video to discuss the detailed solution of that question. The question is part 1. In the triangle PQR, PQ equals PR. The point X is marked on QR such that QX is less than XR. A line drawn through X perpendicular to QR cuts QP at Y and meets RP produced at Z. Draw a diagram and include this data. Prove that the triangle PYC is an isosceles triangle. That's part 1 of the question. Part 2 is, if the midpoint of RZ is S, prove that RZ equals 2SX. Now, we hope to discuss the detailed solution for this question, and you also join with us. Then you may get a clear idea about planning a geometric proof and how to do the geometric proof. So, get ready with a notebook and a pencil or a pen. We will try to explain the steps of the proof. As the first step of the solution, we have to draw a triangle and we have to mark it as PQR. The triangle should be an isosceles triangle. The sides PQ and PR must be equal, so we can mark that PQ and PR are equal, like we have marked on the diagram here. Then we have to mark the point X on QR, that X must be closer to Q. According to the given, in the problem it is given that QX is less than XR. So this length must be shorter than the other part, so it should be closer to Q. So then this point we can take as Q. From Q, take as X. From X we have to draw a perpendicular line to QR. It goes like this. That line and PQ meets at Y, and that line and the line produced RP will meet at Z. So we can produce this line. So the point here must be Z and the point of intersection here must be Y. So this is the rough sketch of the diagram which is given in the problem. Now the rough sketch of the diagram is already drawn, and we have marked the given relationships. And using these given relationships and using our knowledge about the previous theorems that we have learned, we can identify some new relationships. The one is, you know that triangle PQR is an isosceles triangle. Two sides are equal. If two sides are equal in a triangle, the angles opposite to those two sides also must be equal according to the theorem of isosceles triangle. Therefore, these two angles must be equal. We can name them, we can give them one common algebraic symbol. We have given it as A and A. Those two angles are equal. And the line drawn from X is a perpendicular line to QR. Then the angle formed by QR and XZ must be 90 degrees. So we can just mark it like this. And now these are the additional information, additional relationships. Now you find two right angle triangles. One is RZX. In this right angle triangle RZX, angle X is a 90-degree angle, angle R is given as A, and we know the sum of the interior angles, the acute angles of a right angle triangle. There are two acute angles. In addition to this right angle, the other two acute angles must add up to 90 degrees. So then only the sum of the three angles give 180. So the angle X is 90, the other two must be add up to 90. Therefore, to find the remaining angle other than this A, we have to subtract A from 90. So the other acute angle, we can decide the size of that angle must be 90 minus A. So Z must be 90 minus A. And when you consider the right angle triangle QYX, there also the angle X is 90, one acute angle is A, then the other acute angle must be 90 minus A. And you can see here there are two equal angles, those are vertically opposite angles. Therefore, the vertically opposite angle to QYX, that is ZYP, that also must be 90 minus A. Therefore, we can mark the 90 minus A as the size of QYX and the size of the angle ZYP. Now, what we did so far is basically we drew the rough sketch and marked the given relationships, and using those given relationships we identify some additional relationships. So that is our ability. If you do not have that ability, the proof will be unsuccessful. So anyway, we identified these two angles must be equal, therefore we assigned them A and A. The other two angles, angle Z is 90 minus A, and angle QYX is 90 minus A, angle ZYP is also 90 minus A. So this is very important step when you do a geometrical proof. So far we didn't write anything as the proof. Now this step we can name as planning the geometrical proof. We studied the diagram and included additional relationships. If you do these things, you have shown that you are on the correct way of doing the geometrical proof. Now we can now the proof, the first one we have to prove that the triangle PZY is an isosceles. Now everything is, now we have identified. Now in isosceles triangle means there must be two equal sides. If two equal sides are there, the angles opposite to those sides also must be equal. Now here these two interior angles are 90 minus each, 90 minus A. That means those two interior angles are equal. Then easily we can decide that the triangle PZY must be isosceles, because two angles are equal, interior angles, then the sides opposite to those two equal angles also must be equal. That means PZ must be equal to PY, then PZY, the triangle PZ must be an isosceles triangle. So now mentally we have already done the proof. Now we have to write the proof very carefully, step by step. Now we are going to write the proof. There is a standard order of writing the proof. Firstly, we have to write the data. So that is the basic information given in the problem about the diagram. Then next we have to write the what we have to do, that is to be proved. First part is the triangle PZY is isosceles. Then we have to write the statements gradually, step by step, about how did you come to the conclusion that the triangle is isosceles. Firstly, we have to write about those the A means the equal angles of the isosceles triangle PQR. So about A, we can write this statement: PQR equals angle PQR equals angle PRQ, that is A. Reason is the triangle has two equal sides. And then we have to write the statement about this perpendicular line, so that is 90. The reason also given in brief, we have given the reason. Then what we have to do, we have to write about 90 minus A, that is XZR. XZR is 90 minus A. XYQ also 90 minus A. Then another 90 minus A is there. Those are vertical opposite angles. Therefore, this angle also must be 90 minus A, that is ZYP. So, now we have written the information or the relations we obtained as statements like this in order. Firstly about A, then about 90 degree angle, and about 90 minus A. Now we have come to this level. Then what will happen? Now according to the statements we have already written, the conclusion must be YZP, angle YZP, YZP must be equal to the angle ZYP. So that is the conclusion. Both are 90 minus A. Now, if those angles are equal in the triangle, the sides opposite to those angles also must be equal. Therefore, YP must be equal to ZP. So those are opposite side to the equal angles of the triangle PYZ. So if two sides are equal, the triangle must be an isosceles triangle. So the writing, don't be hurried to write the proof. Before you write the proof, you have to plan the proof and include the identified data or the relationships on the diagram. Then only you have to write the proof, writing the steps or the statements step by step clearly and with the reasons. So this is the proof. So this is just like we explain to somebody else about the conclusion we arrived at without any confusion, very, very clearly and gradually we explain our steps of coming to the final conclusion. So that is part 1 of the question. We will see what is the solution for the part 2. Now we have come to the second part of the question. It is like this: if the midpoint of RZ is X, prove that RZ equals to SX. So first we have to mark the point S at the midpoint of ZR, and we can join S and X. Now we have to think about some method to come to this conclusion: RZ equals to Sx. Now Sx is drawn. Now here so far we can't identify any line segment which should be equal to S6. No other information are given. but the S is the midpoint of ZR of the triangle ZXR. Now, in this type of cases, we will have to join an additional part to the diagram, which will helpful to come to find new relationships. That is called in geometrical proofs, that is called a construction. Now here one midpoint is given. Midpoint theorem we can use if midpoints of two sides are known. Here only one side is known. Converse of the midpoint theorem says that midpoint of one side, from midpoint of one side, if you draw a parallel line to another side, the other side will bisect. Now we can try that theorem, and we can draw one parallel line to ZX from S. So we will see what will happen. So if you draw that one, and that line, we can say that when you draw it, it will meet the side XR, and we can name it as T. Then this ST, we have drawn it to parallel to the side ZX. So in this triangle ZXR, from the midpoint of ZR, we have drawn a parallel line to ZX, then it will cut the side XR at T. So according to the converse of the midpoint theorem, this XT and TR must be equal. Now some additional relationships are coming out. And again, now since this angle ZXR is 90 and ZX and XT are parallel, the angle STR also must be 90 according to the corresponding angles of parallel lines. So two informations, XT equals TR, XTR, angle XTR equals angle STX. Now sufficient evidence is there to come to a conclusion that these two triangles are congruent. Now if they are congruent, SX and SR are equal. Now we have found a side which should be equal to SX. Now we can, from that method, we can go to the end of the proof. So now we have to write it. Now what we have to do is, first of all, we have to mention that we have added an additional part to the diagram, that is called construction. Therefore, construction we have to mention in the proof. Draw a line parallel to ZX from S to meet QR at T. Now we are going to do the proof. First of all, we have to say that XT equals TR according to the converse of midpoint theorem. Then about this 90-degree angle, STR, angle STR is equal to angle STX, because those two lines are parallel. According to the corresponding angles theorem, we can identify that these two angles must be 90. Now we can consider about these two triangles. Then we can write in triangle SXT and SRT, SXT and SRT, SXT equals TR, XTX angle STX equals angle STR, those are 90, and ST is common. Then according to side angle side SAS, these two triangles must be congruent. If those are congruent, SX must be equal to SR. Those are corresponding sides of congruent triangles. If they are equal, so you can mention the reason here, SX equals SR, within brackets we can write corresponding sides of the congruent triangles. Then this RZ, since this S is the midpoint of ZR, one part, the SR must be half of ZR and ZR must be 2 times of SR. And if SR is equal to SX, ZR must be equal to 2 times of SX also. Now here we have written RZ equals 2SR and SR is equal to SX. Therefore RZ must be equal to 2SX. So likewise we can come to the final conclusion, which is given in the part 2 in the question. We have proved that this RZ must be equal to 2 times of SX. Now again we will discuss what will happen, what we did here. We added an additional part that is a parallel line to Zx from S, and the line meets QR at T. And we proved that the two triangles SXT and SRT are congruent, and because of those who are congruent, SX must be equal to SR, and SR, and the relationship between SR and ZR, we can say ZR is 2 times of SR and SR is equal to SX. Therefore ZR must be equal to 2 times of SX. Now this question number 9 we discussed so far, it is a little bit difficult, maybe difficult or complicated. So many, we selected this problem. It is helpful to revise so many theorems in geometry. And it is, our purpose is to revise in geometrical things or mathematical things which will helpful to you to face to the government paper with confidence. So here, related to triangles, all of the theorems are included in this problem. So therefore, this is a very good example for us to revise larger part of the theme geometry. Then it will helpful to you to revise them and keep them in mind and apply them to different situations in geometry. So this is question number 9, and we will go to question number 10. We will meet with the solution of question number 10 in the next video. Question number 10 has two parts, A and B. Part A is prove that the line joining the midpoint of a chord drawn to a circle and the center of the circle is perpendicular to the chord. That is the part A of the question. We have to prove a theorem. So part B is A, B, C and D. The diagram is given. A, B, C and D are points on the circle in which the center is O. M is the midpoint of AC. MO produced meet AB at P. Prove that angle BCD equals angle PMA. Second part, angle CBD equals angle MPA. So this is the question number 10. You try it and we will compare your solution and our solution whether you are correct or we have to learn something more. We have come to the question number 9 of the model paper. We use this video to discuss the